Good afternoon, everybody. Two little programs today. The first presentation is sawing basics regarding control joint sawing. And just so everyone's aware, the reason why industry put this program together a couple of years ago was some of the concrete joint deterioration issues we were seeing around the Midwest. We thought that a lot of the industry had forgotten of some of the control joint sawing basics. So we did put this program together. We have presented it at numerous workshops the last year or two, and we think a lot of the industry has found it pretty valuable. So there'll be a little presentation on the sawing basics and then one on sealing basics. So we'll go ahead and get started with the sawing basics. Presentation outline, basically why do we saw, equipment types, matching equipment to the project, blade selections, ensuring construction quality, what to do when things don't go right, the sawing window, which is really the most important part of this presentation, and then a quick summary at the end. Nice little slide just showing a nice joint on the left of controlled cracking over a basket or steel, and obviously on the right, an uncontrolled crack. Two types of saw cuts. Initial saw cut, which is over on your left, showing a nice defined controlled crack at the bottom of the saw cut, and then a reservoir cut over on your right. We've included these slides because more and more of the owner agencies, designers have been going to various types of initial saw cuts, sealing them, leaving them unsealed type of things. So that was just a nice slide showing that. Equipment types, basically in the roadwork industry, intermodal, commercial, municipal, there's really only two types of saws that most of the road industry uses. On your left is a wet saw. Two types are a walk-behind saw and a rider saw, span saw. And then, of course, the dry saw, early entry saws, which are gaining popularity. The good news about the dry saw, early entry saws, there's now various manufacturers making it. Before, it used to be basically just the Soft Cut brand. And you'll see some slides to it, but there are now various manufacturers that are manufacturing these saws. The flat saw over on your left, basically the saw that everyone sees on most of their job sites and throughout the industry, cuts in a downward motion, can use it for control joint sawing, widening of joints, full depth sawing of ends, which is what they're doing here. They ran the pour a little long and are full depth sawing the end of the pour. The ride-on saw over on your right, which a lot of the industry uses for the control joint and joint sawing work on the industry. Really the nice thing about that saw is it runs on a high production basis. But the big thing there is it saws everything in an upward, upcut motion, which really keeps a lot of the dirt and debris and slurry out of the saw cut. So it's very effective for removing old sealants and widening joints and getting them ready to accept various types of sealants. This is a crack chaser saw. A couple little pictures here just so everyone sees it. Over on the left is a router. Why we've included this slide is most of the industry, when they have a crack in a new concrete pavement, they automatically refer to routing the joint and typically putting some type of sealer in there. The two slides over on the right are a diamond blade crack chase saw. We wanted to make sure that industry realized that on new concrete pavement, we don't necessarily recommend using those routers. They work off of a high impact star wheel system, so it can and will do a lot of damage to the top surface of your concrete pavement. So we do recommend, depending on the width of the cracks and what you're trying to do with them, there is diamond blade crack chase saws, which you can use for 1/4 inch wide, 3/8, 1/2 inch, whatever you may need to do. But it's less intrusive. It does, like a typical diamond blade, it cuts the joint very well. You don't have all that damage and fracturing and raveling to the top surface. So that is an option, just so you guys are aware of it. This is a span saw. We include this slide as a span saw, basically for big mainline paving type of scenarios. What we like to make sure that the industry realizes, while this is a great tool, great saw, if you look at that saw, you can kind of see in the middle, you can see where it's got two different heads sawing the transverse joints. Basically, they start in your outside edge and in the middle and work their way across the slab, just sawing your transverse joints. The thing we like to make sure that the industry realizes with these saws is they basically run off of that I-beam laser bar system. The thing that always has to be watched with these types of saws is it doesn't take very much for those heads to get out of line with themselves. So they can do some damage when they match their joints in the middle. So you just always want to pay attention to the operator, making sure that those lasers and I-beams stay in line so you don't have overlapping in the center of the slab with the saw cuts. This is just another manufacturer making basically the same saw, and as you can see, they're very similar. They kind of work the same way, two heads on them. This is made by the Spider Systems out of Wisconsin. This was a ride-on saw that was manufactured and was unveiled a couple of years ago out at the World of Concrete. It's capable of actually sawing up to 48-foot wide pavement for center lines and transverse joints. What we thought was very, very unique with this machine, and we were just making mention of it to the industry, is this machine was developed not only to saw cut all of your initial control joints, but it was also manufactured to install sealants at the same time as the sawing. It was able and capable of installing either hot force or silicone sealants. The machine is out there. If you go to SawSeal's website, while in the sealing industry, we don't necessarily recommend sealing joints right behind the sawing application. We just wanted to make sure that industry realize that type of saw is out there right now. This, again, is just another one of the manufacturers that makes those span saws, sawing very wide, transverse, and centerline at the same time. As we get into matching equipment to the project, we would want you to look at production requirements, project locations, construction logistics and traffic control requirements, available work windows, specific project requirements, dust control, water control, things like that, concrete aggregate type and concrete mix design. This is a fairly important slide. All of the diamond blade manufacturers throughout the country basically all work off of this map. They work pretty hard at watching the different types of aggregates in their local territories. So if you're looking for diamond blades for your joint sawing applications, if you guys contact your various diamond blade manufacturers, and there'll be more slides and information to these guys as we move forward through the program. But the point being here is they all, out of their local territories and reps, look at these aggregate hardness and of the aggregates very closely, so they should be able to gear you in with the proper segmented hardness blades to properly saw your control joints. Here's just some supplier catalogs. Again, various companies and agencies, a lot of resources, guides. Here's a catalog from Diamond Products on the left, the Concrete Sawing and Drilling Association in the middle, Husqvarna on your right. Of course, while these are all hard page catalogs, obviously all this information is available on their various websites. Typical page in the catalog, this is the page out of the Husqvarna catalog. Why we include something like this is just to make sure industry realizes all the manufacturers offer a whole range of gas and diesel engines, tier 1, tier 4, tier 5 types of engines, all accommodating different size blades and different types of applications, different horsepowers. They also give you all the recommendations over on the right sides of those pages as far as what types and sizes of diamond blades that they recommend using with those types of saws. But again, they all offer it, and they all do a very nice job helping guide you in for the proper saw and the proper blades to run on their saws. This is just a picture out of their page from Husqvarna. Again, they try and gear you in with the material being cut, the machines to be used, the performance, speed, and life, and then on the bottom, the various types of materials that these blades will cut. Again, guys, all the websites offer you all this information, and it's very easily retrievable. They all typically have local reps that can help guide you if you don't understand some of the information, but it is all out there on the websites for you. Saw blade basics, and this is very important because a lot of the industry doesn't pay attention to this. We're not really even sure that a lot of the industry is aware of this. This is just a good close-up picture of a diamond segmented blade. You can see the little black specks in those segments on that blade. And if you look closely at those little black specks, you can see kind of like a lightning fin or whatever you want to call it from that black point moving backwards. All of your diamond blades are manufactured to be spun in a particular direction. A lot of guys don't realize that. If they flip-flop the blades around, you can get a lot of spalling on your control joints. The blades start cutting hard. You can start to get them out of round. And it's just important to pay attention that while on the blade itself, on the top right in the center hole, it always has an arrow on it. When you put the arbor arbor flange over that hole, you kind of lose that arrow. So you always want to pay attention to the segments so that you put the blade on the proper way each and every time. Just another little picture of how a diamond blade works, and it's showing you the industrial diamonds on this, and it's all showing you the blade rotations. Again, really important for clean, easy saw cuts without smalling and to get maximum life and productivity out of the various diamond blades. Blade styles, these are all typically asphalt / control joint green blades that we're showing you here. They protect these welds various ways, like a slant seg, a radius protection, or an insert protection. What happens is in our control joint sawing applications in asphalt, because it's such a soft and porous material at the time of sawing, it'll wear away the welds and release the segments from the core, which is an unsafe activity. So they make different types of ways of protecting those welds, and these are just a couple of the pictures showing you that. Wet saw blades, and again, this is basically for the control joint sawing applications. We know that they manufacture blades upwards and in excess of 100 inches in diameter, but for control joint sawing purposes, we've listed basically 14 to 36 inch in diameter. Down cut, with or without gearboxes, typically requires water for cooling. In your dry blades, they're anywhere from 6 to 14 inch in diameter. The various RPMs to be run on, they basically all work on an upcut motion. They don't require water cooling around the blades. One thing we would like to point out, and we'll have some more slides along it, with all the changes to the new silica requirements through OSHA, we do recommend, and there are various manufacturers making vacuum collection systems to remove that dust out of the air and protect the environment and the operators. And again, we'll show you some more slides of that. Saw blade selection information requirements. You would care about what size diameter blade can be accommodated on the saw you're looking at, what arbor size is required by the saw, what's the depth of the saw cuts required. The horsepower on your saws affects diamond blade selection. Higher horsepower saws require a harder bond or a higher diamond concentration, more production in cut 3 inches or deeper. Aggregate type and hardness and concrete mix proportions are needed to determine that. Factors, again, affecting selection: compressive strength, hardness of the aggregate, size of the aggregate, types of sand, green or cured concrete, abrasiveness of the aggregate. Again, some more of that information, of course, aggregate type, fine aggregate type, and again, this just gets back into if you're looking at some of the various mixed designs and you work with your diamond blade manufacturers, they can do a really nice job gearing you the right blades for that type of information, depending on your local job site. Admixtures play a big factor in control joint sawing. The fly ash controls it. Consistency of how well the slab sets up. And remember, a lot of that information needs to get relayed to your various saw contractors because they don't realize what's going on with some of these mixes at the time the concrete contractor is making those decisions. Ensuring construction quality as we move forward. This is just a picture of a typical Diamond Products 72 horsepower saw. We'll have a little picture about the tracking, but we just wanted you guys to have a sight of what some of these bigger new horsepower saws are looking like. Typically, control joint sawing, you begin sawing anywhere from 8 to 24 hours after the floating and finishing. Obviously, the time frames are longer due to cold weather and moisture, rain, things like that. One thing industry always recommends is to saw cut transverse joints first. It should be all the time, not most of the time, and it's prior to any longitudinal control joint sawing you would do. The tracking's on your saw, and we'll get into this a little bit more in a couple more slides, but remember, these bigger saws, like we just showed you the picture of, the tracking capability can be set on these saws. Basically, if the guy doesn't set the tracking on the saw and just lets it run through the slab, it's going to pull way left or way right. You want to set the tracking so that when the aggregate and the hardness of the concrete pull the saw a particular direction, you set the tracking so that the saws with minimal work will walk themselves straight through the slab, so that you're not tearing one edge or the other of your control joints. And that's really important. A picture of just a little saw doing a little control joint sawing. These are a couple pictures of probably the two main players in the early entry market these days, and that's a Husqvarna soft cut saw over on your left. That's a Diamond Products version of their early entry saw over on your right. The Husqvarna soft cut saw has their own unique blade, again, upcutting rotations, the skid plates applying pressure to the surface that they're cutting, cut the green zone somewhere in those first 2 hours, hopefully between initial set and final set. We'll get into the blades, the plates, and the blade blocks in the next couple of slides that are up on the screen. This is just Husqvarna's version of hardness and softness of the blades that they offer. They basically use them as a color-coordinated blade, and that's how you would refer to them when you order one of their blades. This is a close-up of the skid plate, and this is really the heart and soul of these early entry saws. It's a good picture up on the left. The picture down on the right is showing the skid plate riding the surface with the blade embedded. One thing to keep in mind is using the proper speed of these early entry saws is really important, because the aggregate itself, if the hardness is too hard, these blades will run up and on top of those aggregates to a certain degree versus cutting through them. So the speed at the pace that the guys are sawing these joints for you is very, very important. Detecting the control joint sawing of the green zone, kind of a picture up on your left showing it ready for cutting. On the right, it's too early, showing the guy stepping on the concrete and the saw being rolled onto it without leaving depressions. Joint protection with the early entry sawing, and this is, again, very, very important. The guy on the upper left showing you how fragile a freshly early entry sawed joint can be. So it's really important that we protect those joints. And again, we have a couple more slides to show you of that. And this is probably one of the biggest keys to success with early entry saws. These tabs up on your left that you guys are seeing on your screen, after you saw your transverse joints, you always need to insert these tabs where the wheels are going to cross these fresh sawn joints, both longitudinally and transverse, every spot that the saw is going to go across those joints. Again, because those joints can be very, very fragile, the saw and the walking itself, you can do damage to those joints. So in order to protect them, you want to make sure that the guys that are doing the sawing for you are taking the time to place those tabs in the wheel zones and wheel placement zones and across all of the joints. First cut early entry system. This is just a little information of the Diamond Product saw that you saw a couple of slides ago. Again, all the different specs for it, the engine, self-propelled drive, maximum cutting depth. Again, it works off of an upcut design. This is their skid plate. Again, very important slide that they're showing you to always check the skid plate before sawing. The other important part of that is a lot of guys feel it's an inconvenience to replace the skid plate when they replace the blades, and you're basically buying these blades and skid plates as a set. Every time that a contractor changes a blade on an early entry saw, it is very important that they change to a new skid plate at the time that they change to a new blade. A lot of guys just don't want to be bothered. They don't want to take the time. Well, those skid plates are very important to protecting the integrity of that concrete surface. So make sure that those guys are replacing the skid plates whenever they're changing a blade. This is a picture of the Husqvarna dust collection system. Again, it's on wheels. It can be worked along with the early entry saws. It removes all that dust out of the air, so it's real important if you're in an environmental area that's very sensitive to it. It also helps protect the operator from the dry dust. As we get into the field issues, this is just a couple of slides of what you see when you see some typical late cracking. This slide was put in there. We kind of sent out a brief survey to a lot of the DOTs. The first one was if the slab cracks before sawing. This is the various things in the states of what they do, like a no mention, omit the joint, omit whether it's in 1.5 meters, does not apply. The second section was if slabs crack while sawing, what do they do? Stop saw cut, do not apply, and it allows skipping joints. We included it because we were just trying to get some feedback from the DOTs of what they were looking for with some of those things. One good reference that you guys have is if you have some cracks on your various concrete pavements, ACPA has a very nice article out there and some specification recommendations for repairing uncontrolled cracks that may occur during concrete placement construction. This is the cover sheet of it. Field issues, and this one might be a little hard to see. A lot of guys think that the early entry saws is kind of a fail-safe system for sawing your control joints. This is a prime example of the early entry saws doing damage to an ultra-thin white topping job in a commercial project that was done up here in the Chicagoland area. You can see where the pens are, all of the spalling that took place on both transverse and longitudinal joints. Problem on this job was there was a lot of square yards, and the saw contractor did it to every lineal foot on this entire project. The owner made the concrete placement contractor come back and clean out all of those joints and apply a silane sealant to help protect the integrity of those joints afterwards. Point being, guys, is the timing saw window is just as important with an early entry saw as it is with a typical wet conventional saw. Again, this is another slide of another job site. You can see on the bottom left how early they were on it, because you can see the depression of the wire wheels or of the wheels of that saw into the concrete surface. And because of the spalling up on the top, they made them put I think if I'm not mistaken, I'm probably mispronouncing them, a Thacolite or something type of sealer on that surface. The problem is it stays black, so they then got to look at that for I don't know how long it lasts. But again, just kind of a picture showing you the damage that can be done with early entry saws if not paid attention to. A couple more pictures of some of the field issues, some more cracking. This field issue, this gets into the tracking importance on these bigger diesel and gas saws. This was a job site in Kansas that the contractor got far behind on the control joint sawing. So he only sawed the initial saw cut an inch or an inch and a half type of thing down. Then he dropped back with the saw to deepen them up to the proper depth. Had he taken the time to make sure the tracking was set on that saw correctly, he should have been able to drop that saw in that initial saw cut, and the saw should have walked itself right through that saw cut. You can see the damage that he did because the saw kept pulling itself right out of that inch-deep saw cut, and the damage that he did to a very large majority of the transverse joints on this project. So again, can show you what can happen if the contractor doesn't make sure that the tracking is set correctly on the saw that he's using. A couple pictures of various types of sawing when it comes into sealant removal and sawing of the sealant for sealant removal. The sawing window, which is really the most important part of our presentation. Things that affect that window, guys, is the ambient air temperature and humidity, type of base that the concrete is placed on, concrete thickness, direct sunlight or shade, blade selection, equipment, and saw cut depth. Defining the sawing window. This is basically the chart the entire industry uses. They've used it for I couldn't tell you how long. Up on your left, too early, you see the raveling, you see the proper sawing window in the middle, and on your right, you see the too late cracking. It's an excellent chart. The problem is, guys, is it doesn't give us a lot of information. And that sawing window changes job to job, day to day. The temperatures change it. Going under a bridge in the shade changes it. Cloud cover changes it. Rain onto the surface changes it. Retarders change it. Everything changes it. So while it's a wonderful slide, just remember, while the sawing window shows you that time frame, and remember that sawing window can obviously be to your left or right and always needs to be maintained and monitored so that you are sawing it in the proper sawing window. A couple different ways of some information and software programs that are out there to help you do a better job and when you're doing your control joint sawing. This is some information that's being put out there by the CP Tech Center. This is the cover sheet for it, comparison of setting times measured using ultrasonic wave propagation with saw cutting times on pavement. Great information. They basically call it the P wave. It helps, again, guide you into when to saw your joints by putting in all the base information into it. This is the other one that's been around the industry. I understand it's gone through a kind of a big change. They've made it a lot more user-friendly. It's HyperPave. And again, I think like Ohio and a couple other states, it's mandatory that they use hyper pavement programs to help their guys determine when to saw cut these joints. It's a lot more user friendly by putting all the proper information. They say really helps determine when you guys should be in there sawing your control joints. Factors that shorten that sawing window. We kind of went through them, but temperature drops and rain showers, temperature rises, humidity, clouds, hot temperatures, sunny, the various types of sub bases that you could have out there, your concrete mixes, rapid early strength, slow early strength, retarder sets, coarse aggregates, just all of those things. And they need to be relayed to your sawing contractor so he's aware of them. And again, your sawing contractor should be looking at a lot of those issues throughout the day and every day so that he's in there in the appropriate time frame. What do you saw first? Kind of a picture of a mainline paving. This gets back into showing all your transverse joints, your centerline joints, skipping joints, which again, industry does not recommend skipping joints. We recommend making sure your saw contractors have enough and proper equipment and manpower on the jobs to saw cut this. Every transverse joint in the proper paving direction, and then saw cut your longitudinal centerline joints last. Basically, the summary: selection of appropriate equipment for the size and expected execution of the construction paving is critical. Ensuring safe and efficient work zone. Inspect the work and verify its acceptability. One other tool that we want to make sure that all you guys are aware of that's out there to help you through some of this information is the Seal No Seal group, who has helped to put a lot of this information and program together. This is just a picture of their website. Feel free to use them. We've tried to help various projects get through some of their problems, but a lot of this information is in that website to try and help you move forward and eliminate some of those issues and answer some of your questions. Some of the tech briefs that the Seal No Seal has put out there, Baccarat absorptions, use of stylings, joint movement, estimators for designing, selecting Baccarats, joint slaps. So again, there's a lot of really good information in their website. Again, this is just some basic information regarding sealing and resealing of our joints. With a lot of the job site inspection going away, from the way it used to be, we're working really, really hard as the Seal No Seal group to make sure that everyone pays attention to the importance of proper joint installation if you or your area are sealing joints. We know that there's a lot going on in the industry regarding should we seal, do we seal, if we're sealing. Basically, this presentation is just to try and help you that if you are sealing and it is being specified, how to help you achieve what you're designing your joint sealing pavements for. The agenda: types of joints in concrete pavements, why seal joints, types of sealants, silicone installation, inspection, project review, issues and troubleshooting, proper hot pour installation, proper compression installation, joint resealing best practices, and crack sealing installation best practices. Basic reasons for joint and crack sealing: minimizing water and incompressibles into the pavement system, reduces subgrade softening, pumping, and erosion of fines and spalling, prevents joint-associated distress, and helps reduce noise and joint slap. Is sealant cost effective? Just a little bit of the information out there. On your top left, basically, the FHWA had put out a tech brief a number of years ago. Basically, the end of their report, it was saying that no, it wasn't an effective effort. Yet AASHTO came back with a new design guide saying yes, it was effective. So again, a lot of the jury is out there on whether it's good or bad for you. One thing that the Seal No Seal group has done, we hired with TTI to do a lot of work looking at the moisture going through sealed, unsealed joints and what it's doing to our various bases below that. There is now a tool out there. This is the screenshot, guys. I would really all recommend you finding this. This will be posted on the Seal No Seal website. This was just released. We're doing kind of the fine tuning into the front outline. We'll be putting it on the website here within the next couple of weeks. We would really recommend you guys to take a look at this report. It was done by Dan Zollinger down at TTI, and he now can take a look at it as a working model to show you what's going on underneath your pavements with the amount of moisture going through your various types of joints and the goods and bads of what can happen to our bases if left unsealed and allowing that moisture to go through them. So this is a picture of the report, and we'll have it available to you here really, really quickly. Percent of total cost operation for sealing of a joint is basically showing you the percentages of the initial saw cut, a reservoir cut, and furnishing and installing, the sealing and cleaning. One thing is, the slide's a little outdated in the fact that more and more states that are sealing joints are going to a single saw cut transverse joint and sealing that. So the widening's really and reservoir cut's not happening, but it's just kind of a slide we put together for an ACPA relative cost study done a number of years ago. As we get into field performance, why seal joints and cracks? Really important points is to prevent incompressibles from lodging in the joints, slab growth, and blow-ups. These are just a couple of those pictures. Again, preventing water from entering the subgrade. You can see the hollowing out down on your bottom left. Picture on the right was a picture that was sent to us guys as they were doing some filling on the pavement voids underneath. You can see the amount of water and moisture that they were pumping out from underneath those slabs. The water damage that can be done to pavements and how powerful it is. This was a joint, transverse joint, that was still showing the sealant in it, and you can see by the water running through it the amount of deterioration it showed on the sidewalls of that joint beneath that backer rod. Picture of a patch job that was done and brought to our attention the amount of wear and tear on the bottoms of these cracks that happen on these concrete pavements with all that moisture going through them. So this is a good side view of a fairly wide crack, as you guys can see. This was the finds of what the bottom of that square looked like and the deterioration that took place. As we get into some of the joint associated distress slides, again, this report done by the CP Tech Center, we want to make sure that industry realizes this is out there and available to you guys. It's conclusions from the investigation of the deterioration of joints and concrete pavement. It was the final report put out there in February 2016. Again, excellent information. If anybody has any questions regarding, maybe they're facing that issue in their territory, and for a lot of you guys, maybe you don't even see it in your areas, but that report is out there and it's got a lot of great information in it. ACPA's got a joint noise estimator. This is important, guys, because this is important whether you widen and seal your joints and the different types of widths. But the point of the app that ACPA has put together is, depending on the width of your widened portion of your joint, it can affect your noise anywhere and including up to 5 dBA at 70 miles an hour on your various joint widths. This app is up and running, available on ACPA's website, and if you go in there, and there'll be a couple slides here, but if you go in there and put all your information in there, it can show you what your various joint widths, sealed and unsealed, can and will do to the various noise in your highways in your areas. This is just a couple of slides showing you those increases and decreases that you may be facing. As we get into this, when to reseal and sealant longevity, not a lot of great information out there, guys, and telling us exactly when to go back in and reseal joints. We'll have another 1 or 2 slides here. But basically, all we can say to you as an industry is, when the sealant is no longer serving its intended function, it's probably time to go back in there and reseal, whether it be because of adhesive failures, co-adhesive failures, or damaged or missing sections and areas of your sealed joints. Ground penetrating radar. This tool in the last year has proven very important to the resealing industry. We have been able to use ground penetrating radar to detect the amount of moisture in the joints and beneath the joints with a really high level of success. While it may not be practical on your various jobs to be using it, the fact is we are using it to see if the application worked. It does work. We're having some really great results with it. So it is an option if you guys are looking at some larger projects and trying to see what the missing sealant or unsealed joints may be doing to your moisture underneath your concrete pavements. So that option is there for you. Defining sealant life. This is really the only information we're aware of, guys, that's out there. Was the Sharp study that was done a number of years ago. Again, various types of sealants and the life expectancies and when to reseal. But again, at the end of the day, our recommendation really is to go out to your various job sites and physically look at the existing status of what your sealed joints look like to make those determinations. As we get into some of the life expectancies of sealant, this is showing a 20-year-old silicone sealant at Fairchild Air Force Base. Great life. You can see that it's still holding up very, very well. This was a study that was done through Craftco a couple of years ago. Same job site, a resealed job, less than a year old, improperly cleaned, improperly installed, less than a year old, and you can see how the whole right side never even gained adhesion. We'll get into the whole proper cleaning method as we move forward, but this was the same airfield, same job site, properly cleaned. We're getting over 20 years, improperly cleaned. We're not even getting a year out of it. Shows the importance of proper preparation of your joints. This is a hot pour. Again, same airfield, same joint. Two reasons why we put this slide in there to show that the hot pour itself is also getting over 20 years. Two things about it. Look at the height of the sealant that it was installed at, guys. One recommendation that we're kind of bucking the trend on, hot pour sealing your joints. We are recommending as an industry that you flush fill your hot pour sealed joints. The traffic and the weather and all of that running over your hot pour joints maintains those joints and helps keep them fluid moving forward. So that's really, really important. The other thing is, while industry thought that some of that bubbling, which you can see in that hot pour joint, was bad for the duration of the sealant, this is a prime example of how some bubbling in the joint doesn't take away from the integrity of the sealant, and you will still and can gain full life out of your sealants if you get a little bit of gassing or bubbling out of your hot pour sealed joints. Design of sealant installation. The installation guides, basically performance depends on design factors. Again, there's an ACPA app website that you can use to help you. There's a couple of slides to show you that. The anticipated movement, construction schedules and installation conditions, required performance period, noise considerations, sealant selections, proper design, specifications for applications, joint preparations, clean, dry, and bondable, sealant installations. Silicone and compressions should be recessed. Hot pour should be flush filled. Backer rods appropriate for sealant type. Primers. A lot of the industry is going away from the primers, while some various sealant manufacturers, if it's immersed in water, do want their primers being used. So we would refer that question back to the manufacturers to get a determination on that. Allowable joint opening movements. Compression and extensions, hot pour sealants, 25% extensions. Silicone sealants, 50% compressions up to 100% extensions. Compression seals, 15% minimum compressions to 50% extensions. Guidelines for joint design, basically showing you the upper widened portion, the various things you're looking at, you know, how wide, how deep, how thick of a bead of sealant is the manufacturer recommending, what size backer rod should you be using in there, and how far below the surface you would typically recommend that to be recessed. So that's just kind of the couple of things that you would want to look at if you're designing a widened joint to be sealed. Manufacturer design tables for silicone. So again, this is another instance where a lot of this information is available to you, whether it be Craftco, Dow Corning, DS Brown. They all offer this type of information to help you design the right tables for their various sealants. And this is showing you the different widths and recesses and backer rods and sealant bead thicknesses, all that information you would be looking for. Compression seal design chart. Again, this is a DS Brown chart. Again, gives you the joint widths and what different types of rubbers that are available to you and that you should be putting into those joints with what types of recesses. The joint movement compression seal app. That is out there by the ACPA. Compression seal joint width calculator. Again, putting in a lot of your local information that you may need and want into it to help that app give you the information that you're looking for. Width of uncompressed seal, the state, location, month of construction. Really, really important, guys, especially at the time of sealing, the month of construction. And then it does the calculating. Compression seals, temperatures, sawing recommendations. So again, it's a great app. Got a lot of wonderful information in there for you. Joint saw cut width, and then it basically gives you all that information that you might be looking for. Again, that's through the ACPA. Let me just kind of get through this again. It's kind of a repeat. Important slide, guys. One thing that we believe industry has kind of lost its vision on. The time of placement for your various joint widening widths and your joint sealant placement makes a huge difference, whether it's in the heat of the summer or the coolness of the spring or the coolness of the fall. Very, very important so that you pay attention to the various crack and joint widths and the types of sealants and recesses that you're using at that time of year when you're doing these various installations. What you may be doing in Arizona in the month of July may be entirely different than what we're doing here in Chicago or Wisconsin or Minnesota. So you always need to be paying attention to that and referring that back to the manufacturers for their input as you look at some of that information. Sealant selection guide. Processes involved in sealing. Again, material selection, your sealant types. Now, there's a lot of sealants out there in the industry. We've just kind of referred this presentation to the basic three that are being used on our roadway systems, that being hot pour, silicone, and compression seals. The backer rods, again, a lot of information through the SNS Group website. Why we've included this slide, they have an open cell rod for a lot of your various indoor and some outdoor applications, your closed cell and your hybrids. Recommendations from industry guys for any outdoor application, an open cell backer rod should never, ever, ever be used in an outdoor exposed to the elements application. It should always be a closed cell or a hybrid. If you get a break in the sealant or any type of problem along the joint, you do not want the moisture burying itself in these open celled serra rods and sitting there in a soaked position doing damage to your concrete joints as time goes on. Should always be a closed cell rod. That's really, really important. Now we'll get into the preparation of sawing, cleaning, inspection, and installations. Backer rod selection use. Again, really the only thing you care here is it should be sized to be 25% larger than the joint width. Yes, it controls the depth of sealant, ensuring proper joint design ratios. It helps force the sealant along the sidewalls, which is really important. The sealants should not, and they don't typically, if they're being used properly together, they don't adhere to the backer rod. Easily compressible, again, shouldn't puncture a closed cell rod and outgassing. But that's just some of the basic information regarding those rods. Showing your sealant types, silicones have non-sag, self-leveling, and rapid cures. Hot pour, standard modulus, low modulus, and compression seals. The silicones, again, while a lot of states are using them on our roadways, we are primarily seeing a lot of the silicones being used in the airport applications. The rapid cures are being used in the expansion joint market and performing very well. Hot pour is being used throughout the industry, and compression seals, again, working very well in various applications in the industry. Non-sag silicones come in a light gray, manufactured for horizontal or vertical applications. They're low modulus. They require tooling. Tooling is very important with it, guys. As you tool a low modulus sealant, the premise with that is by tooling it down is creating the shape factor, but it also creates the sidewall pressure so that you achieve the proper adhesion on your sidewalls that those sealants were designed to. And by tooling it, that helps apply that pressure to your sidewalls so that they work well. They work well in small spalled areas, tack-free 25 to 90 minutes, full cure basically in 14 days. Your self-leveling sealants come in a dark gray, horizontal application only, ultra-low modulus. They don't require tooling. They're great for rehabs or new pavements. Tack-free in about 3 hours, full cure in 21 days. Basically, a lot of agencies use it for AC or PC joints. We ourselves have used it for various applications. They work very, very well. And again, you don't have to tool it, so they can tend to be a little less expensive. A quick installation configuration video. Silicone packaging. Silicones typically come in various containers. You can see the caulk tubes on the bottom, the 5-gallon pails, and your 55-gallon drums. So there's various pumps and different types of equipment to put that various sealants in, depending on how much of it and how big your job sites are. Your hot pour sealants, this is typically how that they come packaged. If they're in a plastic bag, which goes into the kettle, throw out the cardboard box. You know what? On your bigger crack fill jobs, it's always the engineers have typically always used it. Guess what? At the end of the day, you count the boxes times the basic poundage, and you know how much, if it's a poundage pay item, how much was being put in your cracks that day. One good news is Craftco Manufacturing Sealants is being proactive. They have now manufactured and packaged in these containers like this, that the entire container goes into the kettle, so that it eliminates the waste in your landfills and dumpsters and all that. So again, a little more expensive, but you eliminate all that waste, and that's them just being proactive in the packaging portion of those hot pour sealants. Asphalt-based sealants, again, modified asphalt-based to the 15-plus year life cycle. We're seeing a lot of job sites up in excess of 20 years now. Good for asphalt and concrete pavements, different grades available. Compression seals, basically showing you the two ways compression seal comes. The big, huge rolls on your top upper right. Again, great packaging, a little more difficult to use than the ones down on the bottom left. The one recommendation that DS Brown makes with their various rubbers is no matter which way you get it packaged, big or small, that those machines manufactured and supplied by them always be used for compression seal installation. It applies the right amount of lubricant on the sides and always places it in a very nice flat level down below, typically a bevel, and it always places it at a perfect height. So they recommend always using their machine, depending on how it's packaged, to install the neoprene compression seal. Clean and dry isn't an option. This is really, again, kind of like the saw one. This is the heart and soul of this presentation. Clean isn't an option. This is just kind of an old picture of a widened joint, the guy running his finger across there, still seeing the lattice of dry dust and slurry on the side walls of those joints. Why we show this wire brush, we know a lot of industry uses these wire brushes to clean joints. While it can be a useful tool in the saw and seal industry, we caution the industry in using this as a final cleaning method. What the industry needs to remember is improperly used, if they run them too long, if they run them too hot, if the knotted wire ends start to fray and get loose, these wire wheels themselves will create an actual layer of surface on your concrete joints, and then will not allow the various sealants to adhere to it. It's like a glazing that takes place. So again, you can use these kind of as a lightweight application, but should never be used as the final cleaning method prior to joint installation. Water blasting, this just kind of showing pictures in an airport of a little bit of water blasting. We do recommend water blasting whenever possible to remove the bulk of that slurry that's left in there. Just a picture of some widening going on a roadway and the pressure washing both longitudinally and vertical or transverse as they go down the highway. This is a picture of what a properly cleaned installation or intersection joint should look like both ways. Important, takes a lot of time, washing wide, washing deep. Again, we typically recommend the sandblasting operation to happen after proper drying. This is just here in Illinois where they're upcutting, washing, and sealing the longitudinal joints on a project. What it looks like, you can kind of see the path going down the middle of that sawed center line. This is a quick water blast video. You can see the amount of slurry that they're washing out of that widened portion. And again, anything to clean the sidewalls of that joint. And during the sandblast operation, if you can keep that dried silicosis from the operator and out of the environment, it's just a really good thing. So it's kind of a really useful tool if the area you're working in allows you to do that. Now as we get into media or sandblasting, this is a slide of sandblasting some pavement. Why we thought that this slide everybody should see, this was in a large intermodal yard that had been done here on the south side of Chicago. These joints were saw cut, widened, and washed. They were washed at the time of widening. And even after washing, because a lot of agencies hope that the washing could be a final cleaning method, the point being here, guys, you can still see the amount of dry dust being sandblasted out of joints that were pressure washed. So the fact is, it is really, really hard to pressure wash alone and have your sidewalls of your joints acceptable to get full long-term success out of your sealant. And this slide just kind of shows you, even after the water blasting, how much slurry is still left on the sidewalls of those joints. Another picture of them sandblasting the center line after pressure washing. Again, kind of alongside that operator on your left, you can still see the amount of dust being put into the air. This is just them showing the way that they've put a special tip on that for single saw cuts. Remember, it's really, really hard to properly clean a single saw cut to accept sealant. You know, whether it be a .125 or .140, that's really, really hard to clean, even sandblasting the entire sidewalls all the way down to the bottom of the joint. So this company makes special V-shaped tips to help guide that sand in there. This is just a picture of it. Just another picture of it. Again, just trying to remove any of the debris or sand remaining in the joint. Important picture here. While you're seeing the front end of the truck, this operator was lightly blowing out the dust and dirt blowing into the joint just from the job site conditions. At the back of the truck as they move forward is the guy installing the sealant. So you can see the amount of dust and dirt after sandblasting. The job site's blowing back into the joint. So you should be blowing out lightly just ahead of the saw truck or seal truck to ensure those joints being cleaned to accept those sealants. Keeping them cleaned after you've cleaned them. This is a job site that they did the widening. The owner wanted to park some equipment on there before the sealant went in. Well, you can see all the staining that took place into the concrete surface. And the point being here is once that happened, is the joint truly ever clean enough to accept the sealants after the fact? Here's a picture again of an airport apron. And this is really important. It doesn't matter whether these joints are sealed or unsealed. If they're unsealed and having that kind of debris on it and equipment and trucks and construction traffic driven across it, you are going to break apart the edges of those joints and spall them badly. Sealed or unsealed. We've seen this on multiple jobs, and to go in and have to partial depth patch along these joints after the fact is really difficult and really expensive and takes a long time. Our recommendation is try and keep these slabs under construction as clean as you can to prevent that spalling, as we're showing you down on the bottom left, from happening. Just some various spalling again took place. You can see the tire tracks on both joints. Now this is happening within a day or two of the widening before the sealing during the drying application. As we get into the inspection, this is out there, the Seal No Seal group. Again, the information is on our website. We hired with Wish, Jennings, and Elstner to come up with some very simple, easy job site tools in order to make sure that your joints are clean enough and dry enough to accept your sealant. This is just a few slides regarding that information. Right now, they're in the middle of doing some tape pull-off testing, which again, regarding the bonds, which we should have those final results here pretty quick. Cleanliness test on the black cloth that they've used, and again, they're using basically tongue depressors and black cloth with their procedures. Very simple test that can be done on the job sites to see if the joints are clean. And here's a prime example of a joint not cleaned and nowhere near ready to accept the sealant. Here's a joint. Again, you can see the white dried slurry all over that black cloth. It was only pressure washed only. And here's a joint that really looks really, really clean that was pressure washed and sandblasted. Those three slides are excellent slides as far as the whole saw cutting, pressure washing, and then trying to seal, and pressure washing and sandblasting. So again, easy tests you can do to determine whether those joints are clean enough to accept sealant. Top, you can see them cleaned and not cleaned and the differences in them. This was the joint that was wet, so you got no bond, but yet it was clean. And installing our sealant systems. Inserting and rolling the back rod, various tools to do it with. Again, 25% larger than the joint, closed cell backer rods. Don't puncture them when you're installing them, and do not stretch your backer rods when installing them. Another picture of just some different types of hand machines they use to put them in. Installing back rods, just a nice picture of installing of widened joints to accept backer rods. Industry is changing its thoughts on backer rod placements, on widened joints, on a longitudinal and transverse direction in a grid pattern on these pavements. basically through Dow Corning and some other manufacturers, what the recommendation is now coming back is that the backer rod should always be placed in the longitudinal joints first, since basically they're a non-working moving joint. And then the transverse backer rod, and this slide's a perfect slide to show it, then the transverse backer rod should be placed knowing that that's your working and moving joint, and it should be rolled right across the top of that longitudinal joint. Basically, that's an ensuring a totally sealed sidewall condition, because if you try to intersect your backer rods and cut it, what happens is with your silicone sealants and your hot pours, it's impossible to make them literally waterproof, and you get a lot of settlement, and where that sealant, whether it's silicone or hot pour, will take and work its way down into that joint, that you have a lot of low spots, and you have to go back and try and re-top them. Do they really adhere to each other and all that? So the recommendation now through industry is place your longitudinal joints, then place your transverse joints, and roll the backer rod right over the longitudinal joints. This is just a quick little installation video. Again, pretty simple, various types of tools that you can use to make sure you maintain your proper width to depth ratios on your backer rod installation, guys. And installing our hot pour sealants, and again, we've kind of talked about this. Hot pour sealants over on the left should be flush filled. It's showing it in a recessed condition, and again, over on your right is a flush filled condition. Showing your reservoir, really important. This is basically showing you up on that top right, guys, as it shows a little bit of an overbanding. Flush filled with a very proper thin overbanding is great. Again, the traffic and the movement of the joints keeps it fresh, keeps it as a working hot pour sealant. The problem becomes is we see a lot of guys with the various squeegeeing methods put it on way, way, way too thick. Now it's noisy to traffic. It doesn't work. It restricts the joint, restricts the sealant. So the point being is if you are specifying overbanding, the thickness of that overband is very specific and should be paid attention to very closely. And again, that slide's just kind of showing not getting it too thick. This is showing a couple different transverse joints, one with a 3/8" reservoir cut, one with a single saw cut. Single saw cut sealant extrusion, again, while more and more states and DOTs and owners are using a single saw cut, just keep in mind when you seal your transverse joints in a single saw cut method with your hot pour sealant, in the heat of your summer and under various conditions, as your pavement joints start moving together and your pavement starts expanding, you can see it in that slide, you will get your hot pour sealant to come up out of that surface a little bit. Doesn't really hurt the sealant, but it is a little bit annoying at times to the traveling public, so we have to be sensitive to it. But that is the result you can expect by hot pouring a single saw cut joint. Silicone sealant configuration, again, we've seen this before, non-sag and self-leveling. Application, 40 degrees Fahrenheit and minimum and rising. Minimum 1/8" recess, requires tooling. Joint sealant intersection, again, great slide showing you how nice and clean and tight the silicone sealant is in that intersection. Silicone adhesion tests, Dow Corning, Craftco, they all offer you these, and there's another slide to it, but there are various ways to quickly verify the adhesion test that you're getting to make sure that you're getting the proper adhesions out of your silicone sealant. This is a slide of the Dow Corning exact procedure of how to do that adhesion testing. So again, it's on their websites, but you can do that, and there's a perfect slide for it. And this was just a lot of the basic information regarding control joint sawing and sealing, and the questions that you all may have regarding sawing and joints and sealing that between your local chapter state representatives through the ACPA and the ACPA itself and the Seal No Seal group. If you don't find any of the information you're looking for in any of their websites or printed information, I am sure that there's enough support here in the industry through ACPA, Seal No Seal, and International Grinding and Grooving Association. Get us involved and we can answer any question and help you through your various problems.